Good morning to all present here. I'm Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. Rajalakshmi, SNS Rajalakshmi College of Arts and Science, Coimbatore. Today we discuss about in understanding in the SQL transaction guide. First we discuss about the understanding SQL transaction guide, the introduction to SQL transaction and ACID properties in SQL transaction, the starting a transaction and commit and rollback and save points and isolation level in SQL, the explicit with implicit the transaction, concurrency control in SQL transaction and error handling in transaction and example of SQL transaction. This is for agenda. The first we are discuss about understanding SQL transactions. The introduction to SQL transaction. The definition of SQL transaction is represent a sequence of operations executed as a single logical unit of work, and the importance of data integrity is a transaction ensure data the integrity by adhering to ACID properties and safeguarding the against corruption and inconsistency and enhancing the reliability. The transaction management enhance the reliability in database operation through rollback the mechanism during failures or errors. The next one is ACID properties in SQL transaction. The ACID is full form is atomicity, consistency, isolation and durability. The first we discussed about what is the atomicity. The atomicity ensure all operation with a transaction to occur or non on to preserving the system. And the consistency is the transaction transition the database from the valid state to another, occurring the predefined rules and constraints. Next one is isolation. Isolation is guarantees that concurrent the transaction execution do not the interference, the maintaining the accuracy and reliability. The next one is the starting the transaction. The initiating a transaction or initiated using the commands like the begin transaction or start transaction for the clarity. The example for syntax, the start transaction use the begin transaction. We are using the queries insert into table the column values and the values give the values, and committing the changes is after execution the finalize the transaction with commit to ensure all changes are saved. The next one is the commit and rollback. The function of commit, the commit is finalize all changes in a transaction ensuring they are permanently applied to the database, and the function of rollback, the rollback is those changes are made during the transaction restoring the database to its previous state. And example of scenarios, the considering the scenarios where unsuccessful processing require a rollback with a successful update necessity and commit. Next one is the save point. Understanding the save point is create the intermediate and checkpoint with the transaction, allowing the targeted rollback without affecting the entire transaction. And usage in transaction, save point the facilitate and greater control by permitting the user to onto the specific operation selectively within ongoing the transaction. The practical example, for instance, after inserting the multiple records, the rollback to a save point and reverts only the specified changes. Next one is the isolated level in SQL. The isolated level in SQL is a decade of how transaction visibility and concurrency and are managed in a database system. And read uncommitted allows the transaction to read uncommitted changes from other transaction, the increasing the concurrency but risky the dirty reads, and repeatable read and seriable, and repeated read prevents a non-repeated reads. The seriable is ensure the complete the isolation and preventing the phantom and reads leads together. And explicit with implicit transaction. The explicit transaction defined or user defined, allowing the fine-tune the control over the sequence of SQL operations. The implicit transaction defined the committed the changes is automatically transaction the individual statement. The simplifying the transaction is management of for users, and the use cases of each type. The explicit transaction are ideal for complex operation, while implicit ones suit the single statement actions. The next one is the concurrency control in SQL transaction. The concurrency management techniques employ the mechanism like looking the strategies to maintain the data integrity during the concurrent transaction execution. Next one is the locking strategies. Is a different locking types such as a shared or a exclusive lock prevent the conflict in simultaneous database access, and the impact of isolation levels is significantly affect the how transaction read write data influence overall database operations. Next one is error handling in transaction. The try-catch blocks. Using try-catch blocks is facilitates the error trapping and enabling the developers to manage the exception automatically during the transaction. The error handling is techniques implementing techniques like logging and alerting and commenting and transaction for robust overall error management in system. The best practice is follow the best practice such as a minimal transaction, the scope and clear rollback pathways to enhance the error resilience. The example of SQL transaction. The real world transaction example, a typical bank transfer involves debiting one account and crediting another within single transaction. And the e-commerce order passing. The order passing is transaction is comprised the updating the inventory, recording sale, and managing the customer order details together. Multi-step data entry for a user registration may involve the several queries being committed only if all succeed. And the best practices for SQL transaction, optimizing the transaction performance, the employees indexing and partitioning the strategies to enhance the transaction speed, especially in a high volume environment. The resource management strategies is efficiently allocate the connections, and the system is resource to balance workload during the peak transaction processing times. The ensuring the maximum database reliability, the implementing the regular backups and redundancy measures, and safeguard against data loss during the unexpected failures. This for conclusion, the critical role of transaction form of backbone of data consistency, the maintaining the accuracy and the reliability of during the operations, and ACID principle adherence is essential of ensuring transaction integrity, the fostering user is trust in database system. The long-term data stability is strong transaction mechanism ultimately support the long-term data stability, the minimizing the corruption risk and enhancing reliability. Thank you.